Hello everybody, welcome back to Advent of Code. This time I will be solving day 24. So let's see the problem description. The first part of the problem is relatively simple. So you have a list of hailstones given by their current position and their velocity at that point of time. And we need to know how many of those hailstones will collide within a given test area. So basically it's just calculating intersections of lines, but we need to make sure that they collide in a given area and also that they collide in the future and not in the past, given that current time we are looking at them. So what I have taken is the sample code, and now I will be writing this, and I will be using for this purpose a package called math.net spatial, which is very helpful in this case because it will give us all of those basic primitives, so we don't have to write intersections of lines ourselves, and that means that less math for me and more coding instead. So let's do it. So input equals file read all lines of our input txt. So what I will do is I will have lines, which will be a list of line 2D, which is from math.net, and I will read those lines from the input. So for each line, I will take parts. It will be a line split by at symbol, and then for positions, I will split, or I will have to do string split options, trim entries, just to trim it. Then positions will be line parts 0 split by the comma character, and again string split options, trim entries, and the same thing for velocities. Okay, so we have velocities and positions read out, and now we get the x coordinate, so it's going to be positions 0 double parse position 0, and the same for position 1, so it's y, and var vx is going to be velocities 0, and var vy is going to be velocities 1. And so I grade the line. So the line will be given by a starting point, which is xy, and end point. So that end point will be x plus vx and y plus vy. So now we have the lines read in, and now we're gonna calculate the intersection. So intersections, it's going to be initially 0, and we'll be going through the list of lines by a for loop. So it's going to be first line ID, and it's going to be lines count, and we are going to do is again a for loop, second line ID, lines.count, and we don't want to have a duplicate, so I will be going first line idea plus 1. So now we have first line and second line, and we need to figure out the intersection. So I can do if first line intersects with second line. This is a feature of the math.net library actually. So if it's intersection, so now we have an intersection, but we need to check if it's happening in the future and also if it's happening within our area. So we need to set some min value and max value for our test area. Test area min, test area max, and now we need to get those values, and those values are this and this. So these are our test area values. So now if intersection x greater than equal test area min and intersection y greater than test area min, and then if it's less than max and y is less than max, so in that case, or yeah, if it's this way, we need to also check if it's happening in the future. So to check if it's happening in the future, what we could do, I just output the result here so I don't forget. So what we could do is to create a new line that has start point the same as the lines and end point equal to the intersection. So first line, first intersection. So it's going to be line 2D with first line start point intersection as the endpoint, and the same for second line intersection. And now we can check if the direction of those lines is the same. So if first intersection direction equals second intersection direction, but we need to use some tolerance because we are using doubles, so it could be not accurate. And second intersection direction equals, oh, this is wrong. This should be first line direction, right? So second line direction, and again, some tolerance. So we are not taking it complete as equals. And now if this passes, then we are safe to say this is an intersection. We are counting intersections. So this is, I think, the implementation that we need. So we can test it against our sample input. And it's given us 0 because the sample input is using a small area for testing. So I just will copy this comment out and use that smaller area. So 27 here. So let's try to see what happens there. And we have 2, which is exactly what the description of the problem says. So 2 paths cross inside the boundaries. So let's try this same thing with the full input file from here. So I will take this, copy into input and run it. So let's hope it's 28,000. So let's see, 28,000. And that is correct. Okay, so we have the first part of this problem finished. So let's look into the second one. All right, so this second part of this problem of day 24 is very complex, and I was kind of wanting to avoid it for a long time, and I couldn't figure it out. So in the end, I decided that it would be useful to follow guidance from one of the solutions on Reddit, which takes the problem and makes it more linear algebra based. So let's see if I can implement the approach that's described there. So basically, they take the hailstones and imagine as if the hailstone number 0 is kind of our 0 point in the coordinate system, and then all other hailstones are relative to that specific hailstone. So their velocities and their positions are relative to what is the velocity of the hailstone 0. And then it takes the next 2 hailstones, and based on those positions and velocities, it calculates using linear algebra the collision point against the rock, and then based from that, it calculates backwards the original position and velocity of the of the rock. So it's a kind of very mathematical problem, and let's try to see if we can use this solution to solve this as well. So I will have my sample here, and I'm already reading in all the hailstones, but I will need to read them in a different way. So I will have this open here. So what we will do is we have to split. So we have positions and velocities, and we will just store that somewhere in a struct. So let's create a class hailstone or record hailstone, which will be let's do double xy double something like this. And yeah, this is kind of useful because it's already a method that kind of generates a new hailstone based on velocity, based on the velocity. But we would like to do something like public hailstone relative to hailstone or a source, and it would do exactly this. So like it decrease the position and velocity based on the given hailstone. So this will be useful, and we will use this to read in the content. So it will be hailstones. We actually will not need that many of them, so I will just do hailstones add, and it's gonna be new hailstone, and this, and we don't need, we need doubles here. Okay, we'll get rid of this because it leads nowhere, unfortunately. We actually need also z coordinate here this time, so we'll do this, and we will do this. So x, y, z, vx, vy, vz. And the question is it the hailstones are... So those are integers, so I can probably just use let's use longs so that we are sure that we don't go out of the range. See what's the range there. That's quite a big number, so but it should be enough for long to cover. So let's do like this. These should be all longs as well. Long and long. So we have the hailstones, and now we need to figure out how to actually... Oh, right, I didn't add it here. So long z and long vz. Okay, so we have this, and then we also need to add it here. So source z and z, and then we have source or vz minus source z. Okay, so we have this, and now we have read the hailstones, and we will take hailstone 1 will be hailstones 1 relative to hailstone 0, hailstone 2 relative to hailstone 0. So we have now the two hailstones that we work with, and now we need to figure out how to... So we calculate the collisions, which is this, time times v2. There is the calculation of multiplication and product of vectors, which gives us, cross product gives us 0, because those, like the collisions must happen on a straight line. So as a result, it like goes through various kinds of manipulations with those calculations and gives us the final coordinates and solutions. So yeah, so we have T1 and T2. So yeah, let's do this. Okay. We need to calculate T1, which is the time when the collisions will happen. So yeah, so it makes sense. I was just confused a little bit. So we calculate the cross product there, and then do the dot product, which gives us simple single number, and then you can divide those single numbers. That's fine. So we go T1 equals minus. Then it's hailstone. So we create a vector 3D from hailstone 1 x y z. Oh, that's we have something from Copilot there. So let's do P1 equals this, P2 equals this, and then we have V1 equals this, and V2 equals this. So we have all the values there. We can use that quite easily now. So let's do P1 cross product P2 times V2 divided by V1 cross product P2 times V2. Okay, so we get this nice fraction. What is the issue here? I have two little parentheses here. So now we have T1 and T2 is P1, P2 times V1, P1, V2 times V1. Is it correct? Just verify everything is in order. So it seems so. So we have the times now, and we should be able to now calculate the position, the original position, the original velocity and position of the rock. So it's gonna be, so we first calculate the locations in absolute coordinates. Absolute collision 1 is going to be hailstones 1. Yeah, it's going to be new. Sorry about that. Let's quit Teams now. So it's going to be vector 3D. I'll maybe create it. Absolute position 1. It's gonna be new vector hailstone 1 1. So position 2 is gonna be this, and absolute velocity is gonna be this and this, and now we can do absolute position 1 plus T1 times velocity, absolute velocity 1, and then we have this for the second collision, and now based on those we can calculate the rock velocity and position. So it's gonna be absolute collision 2 minus absolute collision 1 divided by T2 T1. So we calculate the velocity based on the difference of collisions and times, and then we get the absolute the source position by removing T1 times velocity. We get the position at the start. So that's the position. And based on that, we should be able to get the solution to the problem itself. So let's see if this works. So we need to add up those positive coordinates. So we do console right line, position plus and plus, and let's see what happens if I run this. I have no idea if it was gonna work. It should. It makes sense, and I have no other idea because I have no idea myself. So I'm pretty happy that I found actually a solution that I can at least understand. So hopefully it will do something useful for us. So let's see if it works or not. And it does work. So we have finally, after a long procrastination, I finally solved day 24 of Advent of Code 2023. So there is a last day ahead of me. And that last day, I decided it would be nice to do this day as a live coding session. So next week, on Wednesday probably, I will do a live coding session when I will try to solve this last problem of Advent of Code 2023, and then we'll hopefully have the whole Advent of Code behind me, even though it's already June of 24, but still it's nice to have the completion. So let's try it. It's gonna be fun. So I thank you for joining this video, and subscribe if you want to see more of those. And I will see you in the next one. I will also try to do the AI solves this problem. So let's check out that one as well if you're interested. And yeah, happy coding and see you next time.